In this video, I'm going to be showing you how to do your LTA4 analyses. This is where you collected data using Google Forms, and you're going to enter this data into StatCrunch to conduct a t-test to see if your hypothesis is true. So first off, just to show you how to get data from your Google form, if you go to your Google Forms, which you can get to by going to forms.google.com, it's going to load up all your available Google Forms. Just click on whichever one you collected data with. And if you have data that's been entered in, this is just a temp file which doesn't have any data. But how you get to your data is you just go view responses. Now, like I said, this data set doesn't have any responses in it, so it's all just blank, but it has all of the items up at the top. Let me go ahead and show you what it would look like if you had a survey with data included in it. So I have a version of that here with the demographic questions I collected. And if you go view responses, just going to open up a Google Sheets file, and this actually includes all the data. The one column you'll get that you don't need is this timestamp. You can just ignore that one, but the rest of it goes along with your data set. So to export this into an Excel file, you just go File, Download As, Microsoft Excel file, and then you just save that wherever you like. Now this is just demographic information, not too interesting. So what I'm going to do is I'm going to pick up a little example data set file that I collected from a previous class. In this I collected in Google Forms, and then make this a little bit bigger for you guys, and then download it into an Excel file. So for this one, basically I asked them how many people they'd had sex with. You get some low answers like 0 all the way to 40. Gender was male and female, and then this was an impulsivity scale. So impulsivity is related to things like having extraneous thoughts, often changing hobbies, having a hard time sitting still, frequently buying things on impulse. So all these measure different aspects of impulsivity. And you notice when I originally got my data from Google Forms, right here it puts in their actual responses. So they could have said, agree, strongly disagree, disagree, strongly agree, or in here, or the middle one is neither agree nor disagree. And actually I have an example of this whole response scale right here. This is a handy file that you're going to be using to convert some of your Excel data into something that's more manageable for StatCrunch. So this is the actual scale I had for this one. I just used as an example here. So it goes from strongly disagree to strongly agree. The thing is, if we collected a scale, we want to turn these words into numbers. And this goes into how to do that. We'll hold off on that for now. Let's say that your experiment, and all your experiments will have one independent variable that has 2 levels, and then a DV that's continuous. Let's say we had a simpler version of this experiment. We'll just get rid of this for now. We'll come back to that later. But let's say we had a really simple version of this experiment where our independent variable is gender. It's already divided into 2 levels, male and female. And then our dependent variable is sex count. And that has obviously a continuous variable. It's just anywhere from 0 to how many people had sex with. So if this is your data set, then this is really easy to import into StatCrunch, and then to do your survey analyses with. So what we're going to do, let me just save an example of this. I'll save this as example data set simple. So this is as simple a data set as a group is likely to get, although most of you guys have more complex data sets than this. But let me just show you how to do this analysis if you have a simple data set. So go to StatCrunch, go ahead and log in. And then under My Data, just click Select File on my computer and select your Excel file. In this case, I'm going to look at example dataset simple. And you can give it whatever name you want. I would suggest sharing it with everyone just in case you want to share it with someone later on. And then click Load File. And in this case, it's just going to come up very simply with sex count and gender. So let's say that we had the hypothesis that we thought males would be having a higher sex count or having sex with more people than females. In fact, let me go ahead and open up an Excel file and write out that hypothesis. because we'll also be writing out a result statement. We make this a little bit bigger so it's easy to read. So we could say, hypothesis, we predict that males will have sex with more people than females. And so for our results, we first have to test out this basically between group difference. Is there a difference between sex count between males and females? And the best way to figure out a difference between two groups is through a t-test. So to do that, just go stats, t-test. We have two samples, male and female, and we have data. So t-stats, two sample with data. And for this one, the values in, that's our dependent variable, it's going to be the same for both. In both cases, it's going to be sex count. And then our where, in this case, we'll make one group gender, add column, equals male. And make sure that this is matching your item response exactly. And then sample 2 is just going to be gender equals female. Hit OK. And there's nothing else we need to do here. All you then do is to compute. And it comes up with these t-statistics. And in this case, we usually just jump right here over to see p-value, that's the significance. If this is at or below 0.05, it's a significant difference. And in fact, in this case, it is. So just looking at this, we don't know whether men were higher or women were higher. We just know that there's a difference. So to figure out which group is actually higher, we need the averages of both. So go to stat, summary stats, columns, columns, there we go, and go sex count grouped by gender. And all we need for this is to go in, mean, standard deviation. So here we're looking at differences in sex count between the gender. We're just going to see the in, mean, and standard deviation of each group. Go compute, and here we have the actual figures. And it looks like our hypothesis was correct, that guys had an average of about 3 sexual partners as at the time of the survey, and women had an average of 1.4 sexual partners. So now with this bit of data, we can write up a result sentence. We could say something like, confirming our hypothesis, it was found that men had more sex partners, and we want to put in the mean and standard deviation for men. Right now, I'll just put that as a placeholder. Compared to women. And then we also want to put their mean and standard deviation right there. So first you just want to say what the difference was between the two groups. So men had more sex partners compared to women, and then mean and standard deviation. So let's go ahead and put in those statistics right now. So the mean for men, we always want to round to the 100th place, was 2.95. And the standard deviation, shows it right here, was 7.05. And for women, their mean was 1.41, if we want to round it up, which we always do. And their standard deviation was 2.14. And a little comma at the end, because then what comes next are the t-statistics, which you're going to get from this box right here. So the first one, you just want to put a lowercase t. You want to always italicize your acronyms here. So M's, SD's, T's are all italicized. Then in parentheses, you want to put your degrees of freedom, or DF. And you can see that right here in this table, it says DF equals 335. So let me put just a 335 right there. And then you want to put an equal sign and then put the actual t-statistic, which is right here, and it's 2.98 if we're going to round that up. And then you want to put your p-value, italicized p-value. And in this case, since the p is below 0.01, and when 0.01 is as low as we can report in APA, because that goes to the 100th place, we'll just put in below or less than 0.01. And the last thing you want to put in here, just because we're going to include a graph too, is put in figure 1. So this will be your result sentence, basically. So you have your hypothesis, results. This is what's going to end up going on your poster. And then right here where you said figure 1, you're going to also include that on your poster as a means plot. So the last step here to look at our hypotheses is just to basically draw out a graph showing this. And the best graph I find is a means plot. So if you go graphs, means plot, again, you're just going to put in your dependent variable and then group by gender. Nothing else to change here. Hit compute, and basically there you go. You have sex count, males and females. Don't worry too much about these bars. These just show the standard deviations here, but you can definitely see the males are a lot higher than the females. So to pop this in the Word document or to pop it into a PowerPoint or whatever format you want to do, just go Options, Copy, and then you can right-click, go Copy Image, and then right-click. Go ahead and click Paste Special and make sure Picture is selected. So again, it's right-click, Paste Special, select Picture, hit OK. And there's our graph. And then you should add a little title to it saying like Figure 1. Oh, actually, before I forget, you should italicize Figure 1 for correct AP formatting, and then give it whatever title makes sense. So you go average amount of, or average number of sex partners of males and females. Whatever makes sense. All right, there you have it. So you have your hypothesis, your results, and then your figure. So that was a case where our data set was very simple. We already had a continuous dependent variable and a categorical independent variable at 2 levels. But let's go to our more complex data set. In fact, let me go ahead and close all this out, minimize this. So for our more complex data set, which we have over here, let's say, let me zoom in on this again. Let's say that instead of just having males and females be our independent variable, we had this impulsivity score. And what we really wanted to figure out was if those who are high in impulsivity had more sex partners than those who are low in impulsivity. So in this case, we're not even interested in gender. Let me just go ahead and delete this out. So we just have the data set that we're interested in. And this is what a lot of you guys have, is basically a scale measuring either your dependent or independent variable. In this case, it's the independent variable. So if you have a scale, there's a few things you need to do before you can put this into StatCrunch. The first thing you need to do is convert all of these words to numbers, because obviously we can't do statistics on words. So in this case, you put this over here. If you remember, this is a response scale from strongly disagree to strongly agree. Yours is probably going to look somewhat different than this, but it'll probably still go from something like disagree to agree, or low to high, or something like that. So what we're first going to do is convert this into numbers, and I put this little handy formula in here for you to do that. So you don't have to go by hand and enter these in. Because otherwise, like what we're going to be basically doing is converting strongly disagree to a 1, disagree to a 2, neither agree nor disagree into a 3, agree to a 4, and strongly agree to a 5. So we'll be converting this to a 1 to 5 scale. If you're going to do this by hand, you'd maybe start with this question right here. I often have extraneous erasing thoughts. And for this person, like let's say we copied this over here. For this person, their first item is neither agree nor disagree. That would be a 3. The next one would be an agree, which would be a 4, 4, 4, 3, 3. Oops. And you can see how tedious this is. So rather than doing that for your data set, just copy and paste this formula in here, but you'll have to make some changes to it so it matches your data set. So probably the biggest change is to make sure that all these words in here, from strongly agree to agree, or strongly agree, match your own response. So if your response scale is this exactly, then you don't have to change anything. But let's say you had a response scale from like, strongly disagree, somewhat disagree, somewhere in the middle, somewhat agree, strongly agree, something like that. You just want to change these words to correspond with your own scale. Now, I don't have to do that because, of course, this is using the scale I already have. But the one thing I do have to do is change A1. This marks a data cell with whatever the first item is that I'm trying to change. And in this case, it's actually B2. So if I click on the first item I want to change, it's in column B, row 2. That's pretty easy to change. Let me make another version of this right there. And all I'm going to do is wherever there's an A1, I'm going to change it to a B2. You only have to do this once for the first item, but just go through wherever it says A1, change it. In here, I'm going to change it to B2, but you change it to wherever your first little item is that you want to change. And that's the only thing you have to do. So change your response item wording, your first item location, and then just copy this. I'm hitting Command C or Control C. And then right here, Command or Control V to paste it in there. Take it a sec, but then you have the whole formula in here and you just hit Enter. And you notice it actually didn't change anything. And that's because it's basically recognizing that this is neither agree nor disagree, which is equal to a 3. So once you have your formula in there, make this big again, you can then take this formula, and if you select this little corner right here, you just click and drag, and it's going to fill in all these numbers for you, so you don't have to. And then you can go all the way to the bottom of your data set. Here I have a lot of data points because I interviewed a big class on this. You guys will have about 60 to 80 data points. And then there we go. So basically it did all that work for me. What's cool too is you can then drag this sideways to capture the rest of these items too. So here, let's go ahead and just copy all of these titles over here. So basically we're going to have all the same items, but here we're going to convert them into numbers. And then we're going to take this first row here and then copy this formula sideways. There we go. So that's all the items. You can see if they're agreed, change it to a 4. If it's strongly disagree, changes it to a 1. And then we're going to copy all these, select all these, click on this little box down here, and then click and drag it down, and it's going to copy it for all of the items. There we go. So by using that formula, it saves you a ton of work. Now we have basically all the items, and we have numbers as opposed to these words. And this is what we can use statistically. So that's the first step. Then the second step is look to see if you have any reverse score items. What I mean by that are items that are assessing the opposite of your independent variable. So in this case, most of these are related with impulsivity. So things like I said, I have extraneous or racing thoughts. I like to change hobbies often. I have a hard time sitting down. But there are a few of these that are reverse scored. Let me switch to one of these. So this one, I am self-controlled, is the opposite of impulsivity. To mark this, I like to put like an uppercase R and a colon right there. And that just marks that this is a reverse scored item. So basically it's in the opposite direction, where a 5 would mean low impulsivity and a 1 means high impulsivity. And actually I have the 3 reverse scored items in this survey right next to each other. So this one also, I plan trips well ahead of time. That's low impulsivity. So put an uppercase R there. And I find it easy to concentrate on things. That's also going to be an uppercase R right there. So in this case, we have 3 items that are reverse scored. The rest of these are related to high impulsivity, so we don't have to do anything. Like I often do things without thinking, you often say things without thinking, and I get bored easily. The rest of those are just high impulsivity. So your 3 or however many reverse scored items you have are obviously going to be in different places. Just go ahead and find them and mark them with an uppercase R. Now to reverse score these, I'll do this over here. What we're going to do is take these 3 items. So I'll go and paste these over here, and we're going to reverse score them. So I'm going to take this first item, and also I have this formula in, let's see, not that one, but over here. So it says reverse score items. This is the little formula I'm going to be using. But what you do is you take whatever original item it is, times it by -1, and then you're going to add however many responses you have plus 1. In this case, I have 5 responses. So 5 plus 1 is going to equal a 6. Instead of copying and pasting this in here, since it's a pretty simple formula, I'm just going to rewrite it. So I'm going to go equal sign and select that first data point here, which is a 4, for I am self-controlled. I'm going to times it by a -1 and then add 6, since this is a 5-point response scale. And you see, if it's a 4, there it is, it flips it to a 2. I can also copy and paste this or drag it over to the other 3 items since they're all next to each other. And as you can see for this one, since it's a 5, it flips that to a 1. If it's a 3, it remains a 3. And then just like last time, I'm going to just drag this down for all of our data points to basically make the reverse scored items in the correct direction. So that a 5 means high impulsivity and a 1 means low impulsivity. There we go. So we have original scale. We have the items that are reverse scored. And actually, since these are now in the correct order, we can actually delete this little uppercase R right here, just so that we know these are no longer in reverse order. So now we have at least one version of each scale item that's in the correct orientation with a 5 meaning high impulsivity and a 1 meaning low impulsivity. So sort of the last step we have to do if this is our dependent variable is just create an average of everything. So I could put a little thing here called average impulsivity. You notice we're doing this all in Excel right now because this is easier to do in Excel than StatCrunch. But for average, it's really easy to do this in Excel. All you do is go equal sign and type in average. Open parenthesis and then just enter in all of the items that you want to average together. So for this first person, we're going to average in all of these items. We're going to skip the ones that end in uppercase R, but go ahead and put in a comma. So then we're going to select more numbers. So we'll select the last few here, put in another comma, and then we'll put in our reverse scored items. So here we have all the items in the original scale minus these reverse scored ones, and then the reverse scored ones right here that we've already corrected for. And then once you have all your items in here, just close parentheses and click enter. And it creates the average for impulsivity. So here, again, we're just going to drag this down and create the average score for impulsivity for all of our participants. Oops, I dragged down a little too far. That's okay. You can just select this, hit right click, clear contents. There we go. So let's say that if this was our dependent variable, let's say maybe we're trying to see if men and women were different in impulsivity, then we could just stop here. We basically put in this into StatCrunch with average impulsivity, male and female, and again run a t-test. But in this case, impulsivity is actually our independent variable because we want to see if those who are high and low in impulsivity are different in this one called sex count. So what we're going to do, our last step, is to convert this to highs and lows. So basically what we can do is go impulsivity, there we go, low versus high. And to do this, we first have to figure out what's the average impulsivity score for everyone in this data set. And if they fall below that average, we're going to call them low. If they fall above this average, we're going to call them high. So to figure that out, I like to go to the very bottom of the data set here. It's kind of a big data set for me. And just figure out what the average of the average is. So these are all the participants' average scores. If we average them across, we're going to get the average score for all participants. So in this case, we do the same thing. We go equal sign, average. In this case, we're just going to take all the participants' individual average scores, close parentheses, and if we hit enter, we're going to get the average for the entire data set, which is an impulsivity of 2.98, if we're going to round this up. So now that we have this in mind, this is our average for the whole data set. Basically, if people fall below this, they're going to be labeled low. If people fall above this, they're going to be labeled high. So at this point, we know that the average is 2.98. We could go back up here and just start labeling people individually. So this person's a 3.9. That's above 2. See, I keep forgetting it already. 2.98, yes. So we'd label that person a high. This person's below that. This person's above that. So we could do that individually, or we could again use a little formula. And I have that formula posted in here. So this is the last one. It says creating high and low from a continuous scale. And all it says is it has this little thing. And what you do is you replace, again, the A1 with whatever data point you're trying to change. And here you replace average with your actual average. So what we're going to do is take this formula and change it in a couple of ways and then input it in there. So the first value that we're changing is right here, the average impulsivity, which is a 3.9. But all we care about is that it's in row AB, column 2, or row 2. So we put in AB2. And then our average score is again 2.98. So we have the score that we want to change and our average. So we just take what we have in here, we copy it, and then we paste it in here. So we paste, we notice it changed this to if AB2 is less than 2.5, low, if not, it's high. If we hit enter, you notice again it doesn't change anything. But now when we drag below, it'll change them all to lows and highs. So again, we can just drag this all the way to the bottom. Of course, this is kind of a big data set, so it takes a while here, but it's going to change them all to lows and highs. There we go. So it's kind of quite a few steps to convert a scale to these lows and highs, but that's all the steps you do, and it's all in this data file right here. Oops, not that one, this one. So again, you change your item response from words to numbers. You reverse score any items you need to reverse score. and then you change those numbers to highs and lows. So those are all the steps. Now, when putting this into a StatCrunch file, what you might want to do is delete everything you don't actually need. In this case, all we would need is this impulsivity high-low and sex count. Now, the thing is, if you just go and start deleting all this stuff right now, let's say we selected all this and just delete it, what will end up happening, since we had a formula that referred to a reference number, in this case was AB2, we deleted the reference, so it ends up deleting all these impulsivity scores. So what we have to do before we delete stuff is we select whatever column we want to keep and copy it. So hit Command or Control C. And then go up to here, it says paste, and go paste values. What that's going to do is replace all of these formulas, like if AB da da da, with the actual highs and lows. So go paste values. And if we click on any of these, now they just literally say high and low up here. There's no formula anymore. So once we do that, then we can delete everything we don't want anymore. Delete all this. You probably want to save it as a separate file, just so you keep your original one. So you might say data set, I don't know, computed. Save that on my desktop. And then again, all we do is go through those same steps we did at the beginning, where our DV in this case is sex count and our independent variable is impulsivity high and low. So again, we would just import that into our data file, our StatCrunch file. In this case, I'm calling it example dataset computed. Load file. And we do the same steps. Where you go, let's see if there's a difference. Go stat t-test to sample with data. Select sex count for both, and in this case, it's going to be impulsivity high, low. In the one section, or one value is going to equal low. And the other one, actually, you can just kind of copy and paste this in here. It's going to be high. Hit compute. And in this case, there's another actually significant finding. Go ahead and close that out. Open this up. So for this case, the hypothesis, put this down here, this would be for sort of a separate study, like we predict that those high in impulsivity will have more sex partners than those with low impulsivity. And then our results, so far we know that there is a significant difference. We don't know what direction it is. But to figure that out, go to Stat, Summary Stats, Columns. We're going to select our dependent variable and group by impulsivity, low versus high. All we need is the n, mean, and standard deviation. Click Compute. And here we can see again, those who are high in impulsivity did in fact have a higher sex count. So we can go, confirming our hypothesis. It was found that those high, or let's say who were high in impulsivity, had a higher number of sex partners. Put in the, oops, didn't mean to do that. There we go. Mean, in this case, the mean for high was 2.68. SD, that would be 6.27, compared to those who were low in impulsivity. And that would be a mean of 1.25 and an SD of 1.59. Then we ended it with it was a t-test. The degrees of freedom was 335 again. Our t-value, in this case, it says negative 2.85, but we're just going to ignore the negative for t-tests. So it's just 2.85. And in this case, again, if we rounded it, it would actually be equal to 0.01, because here the 6 would round this to a 5, and the 5 would round this to a 1. So we can actually just put in p is equal, I should say italicized p, is equal to 0.01. And then here, again, we're going to put in figure 1, because let's ignore that we ever had this. Say this is our hypothesis now. And then for figure 1, we're just going to, again, do a graphs mean plot, sex count grouped by impulsivity, compute, and there we have it. Oops, meant to do options, copy, right-click, copy image, and then right-click, paste special, and select picture. There we go. And right here, I could say figure 1 difference in number of sex partners between those low and high in impulsivity. There we go. So I did that kind of fast, but you can review the beginning of the video for sort of a slowed down version of that. But that's how we do that result. So basically, your results are always going to be the same. It's just a t-test comparing two groups. There's your means plot. So again, if it's a scale, you're going to change those to numbers, reverse score the appropriate items, and then convert those to highs and lows before you put it into StatCrunch. But then the process is still the same when it comes to the analyses. Okay, so those are the analyses you do for LTA4.